Hi, pre-calculus students. Welcome to section 2.4. This is a review for you of complex numbers, which are of the form a plus bi or a minus bi, where a is the real part of the number and b is the coefficient of the imaginary part of the number, making them complex. So we actually don't use imaginary numbers in Calc 1. They are used in Calc 2, still pre-calculus, and great review for the SAT. So let's go ahead. So let's take a look at number 1. What is I? So I'm pretty sure you would tell me that I is the square root of a -1, because there is no number in the real realm that you can take the square root of that would get you a -1 when you square it. Obviously, any number that you square is positive. So why do we need imaginary numbers? Because they actually work very, very well in real formulas that help us in engineering, like fluid flow, electromagnetism, any electrical flow actually will have I in the formula, and there's many other applications, okay? Plus, watch what happens. What would I squared be? I squared would be the square root of -1 squared, right? Because I is the square root of -1, and so when you square it, causing the square root and the square to cancel, and you simply get a -1. Look at that. Just by squaring our imaginary number, we now have a value in the real realm. They are not so far from each other. What would let's circle this. What would I cubed be? Well, let me use what I have above. I cubed would be I times I squared, right? Isn't that still I cubed? And that would be I squared we already said is a -1. So that would be a -I. So sorry, I meant to give myself more room. That's smaller than I thought. So I cubed actually in its simplest form is a -I. Again, I wrote I cubed is I times I squared because I can, right? And that equals, I kept my I, and I squared we already said is a -1. So we get a -I. What is I to the 4th? Well, how about if we write it as I squared times I squared, right? Which is a -1 times a -1, which is 1. Look at that. Our most basic integer in our real system is I to the 4th, is just a 1, which is kind of cool because if you're multiplying anything by I to the 4th, it's the same as multiplying it by 1. You get the same answer back, okay? So this means what would I to the 5th be? Okay, well, I like I to the 4th. It's 1. So anytime I write I to the 4th, it's 1. And there is an I to the 4th in I to the 5th, right? So notice this is I to the 4th times I is I to the 5th. I to the 4th is 1, and 1 times I is I. I to the 6th. Let's stick with I to the 4th because there's an I to the 4th in there, and it's just 1. Let's call that I to the 4th times I squared. That is a 1 times I squared, and I squared we said is a -1. I to the 7th is I to the 4th times I cubed. I to the 4th is 1. I cubed, we already said, is a -I. I to the 8th is I to the 4th times I to the 4th, which is 1 times 1, which is 1. So if you notice then, what happens is if you have an exponent on your I, the actual simplified value of that imaginary expression keeps repeating every 4 exponents, right? I to the 1st is I I squared is negative 1, I cubed is negative I to the fourth is 1. Notice now when you go to I to the fifth, it repeats again because of the I to the fourth that are 1 and are in those exponents. Okay, number 2, let's do example 10. They gave you 5 plus the square root of a negative 36, and they want you to write it in standard form, this being the standard form right here. Okay, well, we already have the A, right? We already have the real part, plus this negative 36, I'm going to write as a negative 1 times 36. Now I can break this up into the square root of negative 1 times the square root of 36, right? This expression here is the same as this. And we have 5 plus the square root of 36 is 6, and the square root of negative 1 is defined as I. And I have written this expression on number 10 in standard form. Number 32, they are asking us to multiply these complex numbers. We can do right to left, or we can do first outer, inner, last. Let's do first outer, inner, last. Let's show all 4 pieces. 7 times 3 is 21. 7 times a negative 5i is a negative 35i. Inside, 3 times a negative 2i is a negative 6i plus, now last. Let's look at this carefully. Let's break it into 3 pieces. A negative times a negative is a positive. 2 times 5 is 10. I times I is I squared. All right, let's simplify this. We have 21 negative 35i minus 6i is a negative 41i. Now, notice this is 10 times a negative 1. I squared is a negative 1. So I actually have, I can combine these like terms. 21 minus 10 is 11 minus 41i. Is our answer from this multiplication in standard form. On 44, given negative 3 plus the square root of 2i, write the conjugate and multiply. So first of all, the conjugate is just the same terms with the opposite sign in between. Instead of a plus, I'll have a minus. Here's the conjugate, and they want us to multiply it by the original expression. Let's do first outer, inner, last again. Negative 3 times negative 3 is 9. Negative 3 times the square root of 2i, don't let that throw you. First of all, it's negative 3 square roots of 2i. On the inside, a negative times a negative is a positive. A 3 times the square root of 2, we'll simply write I. Let's be careful with the last. A negative times a positive is a negative. A square root of 2 times the square root of 2 is the square root of 2 squared, which is 2. Or a square root of 2 times the square root of 2 is the square root of 4, which is 2. Okay, I times I is I squared. All right, let's clean up our expression. Notice that the inner terms are eliminate. Negative 3 square roots of 2i plus 3 square roots of 2i eliminate. And we have 9 minus 2. I squared is a negative 1. A negative times a negative is a positive, and I get 9 plus 2 is 11. Whenever you multiply a complex number by its conjugate, you will get a real answer. Okay, number 52. They give you negative 14 over 2i, and they want you to write that in standard form. Notice what this means is that this I is in the numerator, and I cannot have this I in the denominator. So how do I get rid of an I? I multiply it by an I, because then it becomes a negative 1. And I no longer have an I in the denominator. So let's multiply the top and the bottom to keep this an equivalent fraction by I. I now have a negative 14i in the numerator, and I have 2 times I squared in the denominator. I times I is negative 1 times 2 is a negative 2. A negative 14 divided by a negative 2 is 7i. We have written this expression in standard form, or if you want, the real part is 0, and here's the imaginary part. There we go. We're going to do a problem now like number 92. Given these i's to different exponents, they want you to write these expressions either in a simplified form as I, negative I, 1 or negative 1, like we did here. We are going to do that by focusing on the fact that I to the 4th equals 1. So let's do that. How many I to the 4ths are in I to the 16? Well, I to the 4th to the 4th power. Remember, when one exponent is raised to another, you multiply. So this is still I to the 16th, but I to the 4th is 1. Here we go, and 1 to the 4th is 1. And we wrote it as they asked us to. I to the 21st. How many I to the 4ths are in there evenly? Let's see, 5, right? I have I to the 20th. I'm missing an I. This is 1 to the 5th is 1, times I is I. And we wrote it as they asked. Whoop, oh, right there. I to the 34th. How many times is I to the 4th? And I to the 34th, that would be 8. That's I to the 32. I'm missing 2. This is 1. And I squared is a negative 1. There we go. I hope you found that to be a good refresher on imaginary and complex numbers. Have a good day.